In recent years, low Earth orbit megaconstellations have revolutionized the global internet connectivity and accessibility. Starlink network from SpaceX stands out as the only commercial LEO network with more than 4,000 operational satellites orbiting at approximately 500 kilometers and promises to offer low-latency coverage to more than 2 million customers in 60-plus countries. Starlink plans to deploy more than 4,000 satellites in coming years and is competing with terrestrial networks as a global internet service provider. However, end-to-end connectivity in LEO networks is complicated due to several unapparent internal network deployment and management decisions. For instance, satellites are deployed in multiple orbital planes that revolve around the Earth at different altitudes and inclinations. Majority of the satellites are deployed in the 53-degree inclination plane. This results in non-uniform coverage across the globe, as northern and southern latitudes see lesser satellites compared to the equatorial regions. Starlink subscribers connect to the satellites using user terminals, and the satellites relay their transmissions to the ground stations. The ground stations are connected to the internet backbone through point-of-presence facilities, and there are only few ground stations and POPs across the globe. Additionally, the satellites are connected to each other through inter-satellite links. This forms a complex network of satellite-to-satellite and satellite-to-ground station links, which are constantly changing as satellites travel at approximately 27,000 kilometers per hour speed in orbit. Such rapid changes in links can impact the network stability and makes understanding Starlink performance a challenging task. This work addresses this knowledge gap and provides the first comprehensive, multifaceted measurement study on Starlink. Firstly, we analyze the MLab speed test measurements from 34 countries and perform active measurements over 98 RIPE Atlas probes in 21 countries. Together, these measurements provide a comprehensive global view of the Starlink performance and impact of network management decisions, such as ground station availability, bent pipe latencies, inter-satellite links, and so on. We assess the suitability of Starlink to meet the requirements of the majority of real-time internet-based applications by examining the performance of Zoom video conferencing and Amazon Luna cloud gaming. We compare Starlink with terrestrial Ethernet and 5G cellular networks and uncover several behavioral patterns that are unique to Starlink. We perform high-frequency measurements from dishes in Germany and United Kingdom to understand the Starlink network reconfiguration patterns better. We also shield our dish in United Kingdom from more dense 53-degree inclination satellites to understand Starlink satellite handovers. Our multidimensional findings from global and controlled measurements illuminate LEO network's performance and the influence of several unapparent internal network operations on real-time applications. If you are interested, please read our full paper for more details and download our 300 GB of raw data and open-source tools.